So the next concept is integration using trigonometric identities. So what do you mean by trigonometric identities? So you should recall all the formulas, which means in trigonometry we know sin squared x is nothing can be written as 1 minus cos 2x by 2. Okay. And cos squared x can be written as 1 plus cos 2x by 2. Sin 2x is 2 sin x cos x. Sin squared x plus cos squared x is 1, which means sin squared x can be written as 1 minus cos squared x. Okay. Then 2 sin a cos b. How do you express 2 sin a cos b? You have learnt in 11th standard. Sine of a plus b plus sine of a minus b will give you 2 sin a cos b, and then 2 cos a sin b is nothing but the same. When you expand this, you will be able to get, okay, sin a plus b is what? Sin a cos b plus cos a sin b. Sin a minus b is what? Sin a cos b minus cos a sin b. So try to add that, and when you simplify, you will be able to get this 2 sin a cos b. Okay, that is the way how we get the formula. But once when it comes to practice, usually you can write. So 2 cos a sin b can be written as sin a plus b minus of sin a minus b. And then you have 2 cos a cos b is equal to cos a plus b plus cos of a minus b. Then 2 sin a sin b can be written as cos of a minus b minus cos of a plus b. So these are the formulas which will come, which will be using in solving the integration to make the integration simpler, and that will help us to solve the problems in a easier manner. Okay, so these are the formulas. Sin squared x is 1 minus cos 2x by 2. Cos squared x is 1 plus cos 2x by 2. And this on the other way, you can write 2 sin squared x is nothing but what? 1 minus cos 2x. Okay, and this implies 2 cos squared x is 1 plus cos 2x. From this, just cross multiply. 2 cos squared x is 1 plus cos 2x. 2 sin squared x is 1 minus cos 2x. These are other ways also which you can write it. Okay, so these are some of the basic formulas which we'll be using in this chapter for solving a few integration problems. So sin squared x is 1 minus cos 2x by 2. Cos squared x is 1 plus cos 2x by 2. Sin 2x is 2 sin x cos 6. Sin squared x plus cos squared x is 1. Already we know the identity, but here sin squared x is 1 minus cos squared x. And 2 sin a cos b can be written as sin a plus b plus sin a minus b. And 2 cos a sin b is sin a plus b minus of sin a minus b. And 2 cos a cos b is cos a plus b plus cos a minus b. And 2 sin a sin b is cos a minus b minus of cos a plus b. So these are the basic formulas which we will be using in this exercise. So let us solve the problems of this exercise. The first problem given is integrate actually it's from the textbook only. I'm going to solve. Integrate sin squared 2x plus 5 dx. So what did I say in the earlier problem? We know that sin squared x can be written as 1 minus cos 2x by 2. Sin squared x can be written as 1 minus cos 2x by 2. So sine squared x 2x plus 5 is 0. So same thing which we can apply. This can be written as 1 minus cos 2 into 2x plus 5, okay, by 2 into dx. So this can be rewritten as 1 by 2 into dx minus 1 by 2 into cos of, you multiply the argument, cos of 4x plus 10 into dx. So this is simpler form which you know the formulas with which you can integrate. So 1 by 2 will become with the constant, and integral dx is nothing but what? Integral dx is x. So x minus 1 by 2. Integral cos x is what? Integral sin x is minus cos x, and cos x is just a sin x. So sine of 4x plus 10, and this, it's not x, it is 4x. So once again you have to divide by 4 plus constant c. So this can be written as 1 by 2 x minus 1 by 8 into sine of 4x plus 10 plus c. So this will be your final answer. So your final answer will be, the final answer is, you can take 1 by 2 commonly out, which means x minus sine of 4x plus 10 by 4 plus c. Okay, so this is what this is how you integrate using the trigonometric. The first identity which we know, sin squared x can be written as 1 minus cos 2x by 2. So I am able to replace this, okay, 1 minus cos 2. In this case, we have to consider this as x. We have to consider this as x. Okay, sin squared x. So cos 2 into 2x plus 5, which means we are multiplying. Okay, so cos 2 into 2x. So multiply inside 4x plus 10. Okay, so this is how you simplify using trigonometric identities. There is no other problem. Integral cos x by 1 plus cos x into dx. So this is equal to cos x by 1 plus cos x dx. So what I can do is that, so we have to think something where we can make the integration process just a simpler one. Okay, that is our main idea. So what I can do is that I can just add and subtract 1, because 1 is there in the denominator. I can add and subtract 1. So 1 minus 1 plus cos x by 1 plus cos x into dx. I am just adding and subtracting 1, which means I will be able to split as 2 terms and I will be able to simplify. Okay, so this can be rewritten as 1 plus cos x by 1 plus cos x into dx, which means this 1 and cos x I am taking it out, and then with the minus 1, minus of 1 by 1 plus cos x dx. So what happens here? This one, the terms get cancelled. These 2 terms will get cancelled. So it will be left out with only dx. And here, the place of 1 plus cos x is nothing but 2 cos squared x by 2. Why? Because 1 plus cos 2x is 2 cos squared x. 1 plus cos 2x is 2 cos squared x, but we have 1 plus cos x. Therefore, 1 plus cos x, which means I have to divide by 2. I have to divide this argument, okay, by 2. This becomes 2 cos squared x by 2. 2 cos squared x by 2. So this can be written as 1 plus cos x can be replaced as 2 cos squared x by 2 into dx. So what happens here? Will be left out with, so integral dx is nothing but what? X minus this 1 by 2 cos squared. So 1 by 2 is common. So 1 by cos squared is secant squared x by 2 dx. So this becomes x minus 1 by 2. What is secant squared x? Is nothing but tan. So tan x by 2 by 1 by 2. Okay, secant squared x is tan x, but secant squared x by 2 is tan x by 2 by 1 by 2. Okay, plus c. So what will be your final answer? So this is 1 by 2 and then 1 by 2 get cancelled. So the answer will be x minus, okay, tan x by 2 plus c. Okay, 1 by 2 gets cancelled. You will be left with x minus tan x by 2 plus c. So this is your problem. So you have to think, okay, how to make the integration process simpler. In such a manner, we can use the direct formulas or the trigonometric identities, whatever we know. Okay, this is how we proceed. And let us do another problem. Third problem. 1 minus cos x y 1 plus cos x into dx. So how to simplify this? So you very well know 1 minus cos x is nothing but what? 2 sin squared x by 2. 2 sin squared x by 2. So 1 plus cos x is 2 cos squared x by 2. Why? Because since 1 minus cos x is 2 cos squared x by 2. The previous problem what we saw, the same formula only. And 1 minus cos x is 2 sin squared x by 2. And 1 plus x is 2 cos squared x by 2. Okay, using this formulas, when you simplify, this 2 gets cancelled. You will be left out with tan squared x by 2 into dx. So don't forget to put this dx. Dx is very important. With what parameter you are integrating, that parameter is very important, so you are supposed to use this. And this directly you cannot integrate. You have to express this tan squared x as what? Secant squared x by 2 minus 1 into dx. So this becomes integral secant squared x by 2 dx minus dx. So what it is, integral secant squared x is tan x by 2 by 1 by 2 minus x plus c. So what will be your final answer from this? So your final answer will be, okay, 2 tan x by 2. So 1 by 2, this 2 comes to the numerator, it becomes 2 tan x by 2, 2 tan x by 2 minus x plus c. So this will be our final answer. So only the basic identities we are going to use, which makes the integration process simple. So whenever you come across the trigonometric formulas, you can just easily do the integration by applying the formulas, okay, using all the identities. So it's another category of problem. The most commonly expected one category of problem will do integral 1 by cos of x minus a into cos of x minus b into dx. So what to do? So this is the most common thing which we are normally will come across in problems. So what I'm going to do is that I'm going to subtract and multiply and divide with sine of b minus a, which is nothing but a constant value. So sine of b minus b. So into sine of b minus a. Why I'm doing this is that because we have in the denominator cos x minus a, cos x minus b. This cannot be simplified by using any of the identities or such things. So what I can do is that I can just have some method which will help me to simplify this integral in a form where I'll be able to integrate. So I'm just multiplying and dividing by sine b minus a, and this cos, it remains the same. Okay, this cos x minus a, cos x minus a into cos x minus b is as it is. Okay, so what I have done, I have just multiplied and divided with sine minus a, and this terms remains the same. Okay, so then to simplify further, because I have to bring this in the same form as this, so what I can do is that I can bring the sine of b minus a out. Okay, so then what I can do is that I have to write this sine b minus a in the form of cos x minus a, cos x minus b. So how can I do this? Okay, how can I do this? So I have to replace this sign. So sine of x minus a minus of x minus b. So now you can see sine x minus a minus x minus b. So when I remove this minus symbol out, this x gets cancelled, minus into minus will become this. So I'll be getting sine b minus a. So the sine b minus a only is rewritten as sine of x minus a minus x minus b in order to get some term just like the denominator, which means I'll be able to integrate it easier. So this cos x minus a and cos x minus b remains as it is. It is there as it is. There are no changes done to it. Okay, and then once again I can rewrite as sine of b minus a. Okay, and sine of a minus b. What is formula? What is the formula for sine a minus b? Which is nothing but sine a cos b minus cos a sin b. And sine of a minus b is nothing but what? Sine a cos b minus cos a sin b. So we can use this formula here, which means I can bring it in this terms. Okay, so this can be written as sine of x minus a, sine a cos b. This is a, this is b. Okay, so this becomes a and this becomes b, sine a minus b. So sine a, sine x minus a cos b. Cos b is what? Cos x minus b. Okay, minus cos x minus a into sin x minus b. Sin a cos b minus cos a sin b, the whole divided by cos of x minus a into cos of x minus b into dx. Okay, this is clear. So we can just multiply and divide with one constant, and then I can rewrite this constant as the denominator, and then I can apply this formula here such that I can bring it into a term where it will be easier for me to simplify. So this once again, this becomes 1 sine of b minus a into integral, what is this? Sine x minus a cos x minus b cos x minus a cos x minus. So which means when I split the terms, this terms will get cancelled. I will be left out with sine x minus a by cos x minus a. Okay, and then once again, when I take this term, split these two terms, I will be left out with sine x minus b by cos x minus b into dx. Okay, this is clear. So now what is this actually? It's nothing but 1 by sine b minus a into integral sine by cos tan x minus a minus integral tan x minus b dx. So what is integral tan x dx? Can be written as log secant x or minus log cos x. So this can be written as sine b minus a minus of log cos x. Okay, log cos of x minus a, okay, log cos of x minus a, and this once again minus minus minus, so this becomes plus plus log of cos of x minus b. Okay, why? Because we have a formula, integral tan x dx can be written as minus of log of cos x. That is the formula. Okay, so using that formula only we have done. So, and this log a minus log b is what? Log a minus log b is nothing but what? Log a by. So using that, you will be able to write the final answer becomes 1 by sine b minus a into log of, this is, sorry, cos log of cos of x minus b by cos of x minus a, okay, plus. So this will be our final answer. This will be our final answer. So these are all how you simplify using trigonometric identities, which means you should be thorough with all the trigonometric formulas in order to make this process simple. Hope this is clear. So I multiply and divide with the constant, and then I just make some changes such that I get the denominator term. And after that, what I've done, I've expanded using this formula, and then I've split into two terms. Okay, so I split into two terms here, and then I've applied, okay, a formula here, because the integral tan x dx is minus log cos x or log secant x. It becomes log secant x. Okay, with that formula, and I've got the final result. Okay, so these are some of the problems which we can work out by using the trigonometric identities. The one problem will make it. One problem. Sin squared x minus cos squared x by sin squared x cos squared x dx. Just a 2-mark question which can be asked. So what you do immediately, you split into two terms. Okay, sin squared x by sin squared x cos squared x dx minus once again cos squared x by sin squared x cos squared x dx. So what happens next? The sin squared x get cancelled. You will be left out with 1 by cos squared x dx, and then cos squared get cancelled. You will be left out with 1 by sin squared x dx. So direct formulas you have. What is integral secant squared x? Integral secant squared x is nothing but what? Tan x. And cosecant squared x is minus cot x. So minus into minus, this will become plus. So the final answer is tan x plus cot x plus. Okay, so this is how you solve using trigonometric angle. Just think and you will be able to achieve this. So this is clear. So I'm just splitting the terms, two terms, then the direct application of formula. Okay, why? Because integral secant squared x dx is tan x plus c. And then integral cosecant squared x dx is minus cot x plus c. So using these two formulas only, we have